control valves can be classified in various types based on the basis you have chosen for classifying the control valves. For example, based on their construction, their working, their purpose, they can be classified in the various types like globe valve, gate valve, check valve, needle valve, knife valve, right? Various kind of classifications are there, but we are not talking about those classification. As far as process control is concerned, we will classify the control valves according to their failure position. Failure position means, what is the meaning of failure position? Failure position means the when control valve is present in a control circuit, and suppose due to some mishappening, due to some kind of unexpected scenario, the supply to the control valve, what goes to the control valve? In a control loop, the signal to the control valve is given by the controller. So it can be air signal, it can be electronic signal, depending upon what kind of valve it is. If the valve is pneumatic valve, then it will be air signal. So we are talking about pneumatic valve, suppose. So to any valve in a control system, before going to the type of valve, let us understand this, that there is a controller, right? Controller having transfer function GCS. This controller gives output in the form of PSIG, air pressure. PSIG, air pressure. ये भी हो सकता है कि controller is giving the output in the terms of electronic signal and there is some IP transducer. IP transducer means it converts current signal into P for pressure. I for current, P for pressure. IP transducer which converts the current signal into corresponding pressure signal. So I'm not making that. This air pressure goes to the control valve, right? Which is also called the final control element. Control valve. So एक कंट्रोल सिस्टम में जो कंट्रोल वॉल्व को इनपुट मिलता है वो किससे मिलता है? कंट्रोलर से मिलता है. ये चीज ध्यान रखनी है, इसके बाद ही समझ पाएंगे. नाउ वी क्लासिफाई द कंट्रोलर्स, सॉरी द कंट्रोल वॉल्व्स. कंट्रोल वॉल्व्स ये एक बार बात कर चुके हम लोग, फिर भी मैं एक बार दोबारा बता देता हूं क्योंकि थोड़ी सी कंस्ट्रक्शन की भी बात करेंगे अभी. कंट्रोल वॉल्व्स कैन बी क्लासिफाइड ऑन द बेसिस ऑफ देयर फेलियर पोजिशन. On the basis of their failure position. What is the meaning of failure position? Failure position means when this supply fails, then what is the situation of the valve? Fail condition. What is the meaning of fail condition? Write down. Fail position or failure condition. Failure condition for a control valve means, failure condition for a control valve means when, or the situation when the supply from the controller is cut. Means the situation when the supply or the signal means air. When we say air, consider this as signal. कई बार air word बोलूंगा, air word का मतलब क्या हुआ? Air pressure, the air pressure which is coming from the controller. Okay, so a failure condition for a control valve means the situation where the signal or air from the controller to the valve, from controller to the valve. If you understand this, then you'll easily understand the classification of valve. From controller to the valve is cut. Cut means stopped, है ना? मतलब जब failure condition होगी, then how the valve is behaving, based on that we have a classification. It's very simple. I told you in the previous lectures also that process dynamics is about change, right? And life is also full of change. Our daily life is also full of change. So this particular subject I feel really easy to relate with real life situations. Like this is the controller and this is the final control element. So in the when signals are coming from the controller, then how it is behaving, and when there is no signal from the controller, then how it is behaving, that is called the failure position, right? Failure condition, right? सीधी सी बात है कि आपको अगर किसी तरह आप हो यहाँ पे, आपको कहीं से इंस्ट्रक्शंस आ रहे हैं, then you are behaving in a particular manner. right? Suppose your parent is or your guardians are keeping your guardian is keeping an eye on you that how you are preparing for your examination. आप कई बार बाहर जाके प्रिपेयर कर रहे हो, कई बार ऐसा होता है कि आप पे किसी ने नजर रखी हुई है, डेली कॉल्स आ रहे हैं, डेली पूछा जा रहा है कि हाँ भाई क्या हो रहा है, क्या नहीं कर रहे हो, है ना, हैव यू स्टडीड फॉर 8 hours, आर यू प्रिपेयरिंग वेल, कैसी चल रही प्रिपरेशंस, है ना. इन दैट केस योर behavior is something else. Your behavior is like in a particular manner you behave. But suppose if those instructions, those questions, they stopped asking the question, in that case how you are behaving, that is called failure behavior, है ना. The same thing, control valve. When the signal from the controller is lost, the air from the controller, the air pressure from the controller to the valve is lost. In that case, how the control valve is behaving? Is it fully open? Is it fully closed? Right. So on the basis of this failure condition, we can classify the valve in two types. The first type is air to open. Air to open valve. What is the meaning of air to open? As the signal from the controller or as the air pressure from the controller increases, देखो air to open, हवा, pressure, जब pressure आएगी तो वो valve क्या होगा, खुल जाएगा, है ना. The controller air pressure, as the controller output pressure increases, the valve opening also increases, right? This is kind of valve which is called air to open. And suppose if there is no pressure, बहुत सिंपल सा फंडा है ना. देखो कंट्रोलर से एयर प्रेशर जब बढ़ाते जाओ, you are increasing the air pressure to the valve from the controller, the valve is opening more and more. So if there is no air pressure from the controller, the valve will be completely closed. This is its failure position, right? So this will be called as fail close. ये पहले बताया एक बार मैंने, फिर से दोबारा एक बार रिपीट हो जाएगा, थोड़ा सा कोई बात नहीं, है ना. So first type of classification is air to open or fail close. What is the meaning of fail close? Normally when there is no signal from the controller, the valve will be completely closed, right? ये लिख लो, when there is no signal, air to open means when there is signal failure. When there is signal failure, the valve will be fully closed. Yeah, fail close. The valve will be fully closed. Now, many students think ki, okay, when there is signal failure, the valve will be fully closed. So when there will be signal, the valve will be fully open. It's not like that. If there is no signal, the valve will be fully closed. But if there is signal, then depending upon the signal, there will be partially opening of the valve, है ना. Because after that, air to open means the opening of the valve is depending on the signal coming from the controller, right? The more the signal from the controller, the more is the opening. If the controller is giving maximum signal, the opening will be 100%, right? So otherwise, if controller is giving no signal, there will be no opening and the valve will be completely closed. Similarly, the second one, air to close, or should be called as fail open. Fail open. ठीक है. What is fail open? So when there is signal failure, write down, when there is signal failure, when there is signal failure, fail open means valve will be fully open. There is signal failure. Why the signal failure will be there? Due to some unexpected kind of situations. Because valve is not alone in this entire process line. There are various other things. हो सकता है पीछे कुछ गड़बड़ हो गई हो सकता है किसी और कंपोनेंट में कुछ गड़बड़ हो गई हो सकता है कंट्रोलर में गड़बड़ हो गई हो, है ना. So due to fault in any component in the line, the signal can fail. In that case, what is the position of the valve is called fail position, right? Failure position. When there is signal failure, valve is fully open. So when there is signal, the valve will be partially open. It will be closing. The more the signal, the more will be the closing. Valve is fully open. मतलब समझ रहे हो यहाँ पे? देखो तो fail conditions valve की कैसी है, उस बात पे उसके हिसाब से valve को categorize किया गया. Two parts, air to open and air to close. Now, if I ask you, let us take air to close valve. Means in air to close valve, suppose the controller is giving an output of 5 psig. And valve is, let me write here, suppose, for example, for this one, controller output is, let's say, let's have 5 psig. So valve opening is 30%. Just a random example. 30% means 30% of its maximum opening. Now suppose if controller output is 8 psig, what do you think? Valve opening should be more than 30% for air to close valve or less than 30%? See, air to close, more air, air का मतलब सिग्नल, ये वाली सिग्नल, एयर प्रेशर, इसी को मैं एयर कह रहा हूं, है ना, एयर. More air from the controller, right? Close, more closing. More air from the controller, more closing. So opening will be less. Valve, अब आपको closing के terms में याद रखना है या opening के terms में, वो आप देख लो. 20%. Just a random example, it will be less than 30%. Similarly, if you take valve here, suppose air to open, so that your understanding becomes more clear, that's why I'm taking this example. हो सकता है कई बार, एक बार मुझे याद है मैंने क्लास में बहुत मेहनत से समझाया था ये टॉपिक, air to open and air to close, and then direct action and reverse action. But after that, out of 80-90 students, 4-5 students came in a period of 2-3 days कि सर उस दिन ये समझ नहीं आया था. मालूम नहीं, मैंने पूरी कोशिश करी, tried my best, फिर भी कई बार हो सकता है कि ना समझ आए. That's why I'm taking these numerical values. In case if you are not able to understand, पहले भी बात हो चुकी है इसके बारे में, still, in case you are not able to understand, you will be able to understand with the help of these values. So air to open, suppose in some cases, sorry, CO is 5 psig, right? And valve opening is 30%. I'm taking same values. Valve opening is 30%. Right? So when CO is 8 psig, what do you think? See, air increases. Air to open, अगर valve को open करना है तो आपको air देनी पड़ेगी. Air to close, if you want to close the valve, you have to give air. I am giving air, so valve should close. If valve is closing, opening should decrease. Similarly, if you want to open the valve, you have to provide air, you have to provide signal. So air to open means when there is air to open means as the air increases, the valve opens. So valve opening will be more than 30. You can choose any value. Valve opening is more than 30, so let's say 40%. Similarly, suppose air to open, if CO, if controller fails, then it will be, वो आपको पता है. So in this case, suppose air to close, fail open. If controller fails, so controller output is 0. भाई कंट्रोलर फेल हो जाएगा तो कंट्रोलर का आउटपुट क्या रहेगा? 0. कंट्रोलर फेल्स, इट इज नॉट गिविंग एनी आउटपुट. इफ कंट्रोलर आउटपुट इज 0, व्हाट इज वॉल्व ओपनिंग? टेल मी. वॉल्व ओपनिंग इज एयर टू क्लोज फेल ओपन. तो कंट्रोलर आउटपुट 0 मीन्स कंट्रोलर फेल हो गया. अगर कंट्रोलर फेल हो गया तो ओपन तो रहेगा, कितना ओपन? फुली ओपन, 100% ओपन. ये इनकी अंडरस्टैंडिंग है एयर टू क्लोज वॉल्व की और एयर टू ओपन वॉल्व की. नाउ हाउ दिस हैपेंस, लेट अस हैव आल्सो अ लुक ओवर हाउ इट फंक्शंस, हाउ दिस कंट्रोल वॉल्व लुक्स लाइक. नो नीड टू गो इनटू द डिटेल स्ट्रक्चर दैट इस पार्ट को ये बोलते हैं, उस पार्ट को वो बोलते हैं. वी आर नॉट doing the detailed instrumentation and construction of this valve. So let us go through this construction of a valve. Suppose we have this. In valve there are major components, so I'm just talking about the major components. Suppose there is a valve and this part of the valve is called diaphragm. Okay, diaphragm. And over this diaphragm we have a spring. The construction is not exactly like this. You can't have a spring hanging in the air. ऐसे हवा में ऐसे spring नहीं रह सकती. Of course there is body, है ना, there is body of the valve. There is a diaphragm. This is the spring, right? Then there is a stem. Diaphragm, you know diaphragm? Diaphragm can move in case of air pressure increases and decreases. The diaphragm can expand or contract, right? It is a flexible kind of material. Then there is a stem. This is called valve stem. Okay. Yeah, this is called stem. At the end of the valve stem, there is a plug. This is called valve plug. It's not always of this shape. The shape of the valve plug is of various types. This is called valve plug. Okay. Now, where this plug sits, suppose there is a flow. Suppose there is a flow here, and the flow is of this type. Let's say this is the pipeline, right? And this is the pipeline here. Right. Correct. In this pipeline, there are constructions like this. Fine. There are constructions. Okay. And here also we have a construction like this. Correct. The liquid is flowing in which direction? The liquid is flowing from left to right, suppose. And how the liquid has to flow? This is the liquid. This is the liquid. It is flowing. Suppose, let me make a little bit space so that I can show how the liquid flows. A little bit space. Okay. This liquid goes from here and then it travels like this. And then it travels like this. Okay. This is how the liquid flows. Okay. Right. Now, suppose in this case, the actuating signal, actually this signal is also, there are various names. इसलिए मैं सारे नाम लिख दे रहा हूं. This is also called actuating signal. And sometimes we call this as actuator. So the actuating signal is coming from below the diaphragm. This is not a physical stream, it is just a signal. So this is actuating signal, which is also called air pressure or PSIG. आप कुछ भी लिख सकते हो यहाँ पे. This is the actuating signal. Now you think yourself. Suppose as this air pressure increases, the diaphragm will rise upwards. Correct? As the pressure increases, the diaphragm will rise upwards and the spring will contract. Fine? Energy will be stored in the spring. What do you think about this? As the air pressure increases, the stem will move upwards, right? In this position, write down here. As air pressure increases, stem moves upwards, right? As stem move upwards, what do you think? The opening here is going to increase or decrease? As the stem is moving upwards, the opening for flow of the liquid will increase. You can see here, na? ये अगर shift ऊपर होगा, then obviously more and more space will be there. Stem moves upwards, valve opening increases. Valve opening increases, and as the opening increases, in this case, flow also increases. This is what happens. But suppose this is this is a condition where the spring is slightly compressed, then only I have here some amount of flow. But suppose somehow if this signal is completely cut, right? If this signal is completely cut, the spring which was compressed, भाई अगर आप किसी स्प्रिंग को ऐसे दबा के रखोगे, this signal is causing the spring to compressed. देखो ये यहाँ पे fix है ना, this is fixed here. Then if the valve rises upwards, the spring will be compressed and this plug will rise upward, there will be more flow. But suppose if there is no signal, the signal is cut. If the signal is cut, the spring will restore its original position. The spring will regain its original position and this space will be completely blocked. The flow will be completely stopped. That is called fail open or fail close? Fail close. So what kind of valve it is? It is air to open. You have to provide air if you want to open the valve. Air to open. Provide air to open. There should be no confusion here, or therefore fail close. Right now, don't say ki, sir, this is in closed position. No, this is in partially open position. There is some actuating. I can't show the spring is compressed or it is in the original position, but please consider that the spring is already compressed. सीधी सी बात है ना. देखो अगर यहाँ से flow जा रहा है, the valve has moved upwards in the presence of the signal, and the spring is now compressed. So there is a flow from here. But suppose the actuating signal failed, तो spring क्या करेगी, ऊपर से spring वापस इसको इस तरह से दबा देगी, and the stem will move downwards. This entire path will be completely blocked and there will be no flow. So this valve shows air to open valve. Correct? Now a little change in this valve will make it air to close valve. Right? Okay. So let me make that also. I hope ये आपने लिख लिया होगा. And you can see here that depending upon how much this stem has moved, the flow will increase on that, depending upon that only. ऐसा नहीं कि आपने थोड़ा सा signal दे दिया, the flow will be 100%. No. Depending upon how much signal is coming, the diaphragm will move upwards, the spring will be compressed, right? Energy will be stored in the spring and the flow will increase. If there is no signal, the spring will regain the position, the stem will move completely downwards and the valve will be completely closed. Suppose if I do a little change here, we have this valve, right? And here I have spring at this bottom position. Don't worry about the construction. Don't ask me, sir, how you can attach a spring to a valve. If you want to look at the construction, go through some YouTube channels or internet. आपको मिल जाएगा. That is not required. Okay, this is the spring, and somehow this stem is also attached to the spring only. Right. This is just what do we say, that this is क्या कहते हैं उसको, प्रतीकात्मक, है ना? I'm not able to recall that word. This is not the exact construction of the valve. Just to show what is the concept behind this air to open and air to close. है ना? Right. Now in this case, the actuating signal is not coming from the bottom. In fact, it is coming from the top of this spring and diaphragm position. This is the actuating signal. Now you see yourself that if this is the situation, we have the flow taking place, right? We have this flow. I'm making the valves in partially open position only, so that I can explain that how the spacing is going to decrease, right? And the liquid is flowing like this, same as before. Only because I have changed the position of diaphragm. Okay? If I have only changed the position of diaphragm and the spring, you can see that now as the actuating signal increases, the diaphragm moves downwards, the spring gets compressed, right? And this stem also moves downwards. If it moves downwards, आप देखो जैसे जैसे नीचे move करेगा, this small spacing will be completely blocked, right? It will be completely blocked. Okay, there will be no movement of fluid, there will be no flow of the fluid from this point to that point, right? In this case, as air pressure increases, what happens as air pressure increases? Stem moves downwards. Stem moves, it's very simple, air pressure increases, it moves downwards. Here air pressure increases, stem moves upwards, and the flow opening increases. Stem moves downwards, correct? Stem moves downwards. As the stem is moving downwards, what is happening? This small opening is going to decrease. देख रहे हो ना यार, ये ऐसे है आप, ये जैसे नीचे जाएगा ये स्पेस वहां पे जो है क्लोज हो जाएगा, है ना? Valve opening decreases and therefore flow decreases. So what do you think? What type of valve it is? As you give more air, the valve is getting closed. So air to close. But suppose this signal fails. Earlier signal was there, so spring was compressed like this, right? Spring was compressed, the valve, the shaft was, the stem was moving down, right? When there is no signal, the spring will regain its original position and shaft will also come up, and there will be complete flow. The valve will be completely open. So fail open. So what you have observed, that same construction, everything is same, only the position of spring and the position of this actuating signal has been changed, and the air to close valve and air to open valve, or fail close or fail open valve we have. Many books, in fact many standard books also have a different kind of construction. What they do, actually they keep same spring position and same actuating signal, right? But they change the nature of the plug. Instead of having this kind of plug, they provide this kind of plug, and the air to close valve becomes air to open. That is also correct. So if you find somewhere written that air to open valve has this kind of plug and air to close valve has this kind of plug, that is also correct. तो डिपेंड करेगा कि आपके पास कैसा क्वेश्चन आ रहा है, ठीक है. बट व्हेन आई डिस्कस एयर टू क्लोज एंड एयर टू ओपन, आई प्रिफर डिस्कसिंग विद रिस्पेक्ट टू चेंजिंग द वॉल, चेंजिंग दीज stem position and changing the, not stem, the diaphragm, the spring and actuating signal position. ठीक है, ऐसे भी डिस्कस कर सकते हो कि आप प्लग का शेप बदल दो, रिवर्स द शेप ऑफ प्लग, एयर टू ओपन valve will start acting as a air to close valve, keeping rest everything as same. तो अगर कभी ऐसा क्वेश्चन आ गया that suppose you reverse the shape of this plug, right now this is this kind of bucket kind of shape, and then you make it opposite, then air to open valve will start acting as air to close valve. Okay, so ये construction है, ये principle है that why a particular valve act as air to close or why a particular valve act as air to open. ठीक है, construction समझ आएगी. Now there is a question. Now let me tell you one more thing, that when we talk about the stem, the movement of the stem in a particular direction, suppose this stem cannot move for any amount of there is no I mean it is not free to move to any amount of distance, right? The stem movement is fixed. By ek dekho, normally if you see this one, if there is no power, if there is no signal coming from the controller, the stem position will be somewhere here, it will be slightly upwards. If there is a signal, the stem will move downwards depending upon the signal. After some time, there will be maximum stem movement, right? So generally, we consider the stem movement to be positive in the downward direction, right? Ye likh lo. Stem movement is considered positive in the downward direction. Positive in the downward direction. Generally, the stem movement is considered positive in the downward direction. Means suppose if you talk about this one, there is no signal, so stem position was this. Suppose let me make a diagram here that when there is no signal, I am having the stem like this. Okay, this is the stem position. Just notations, representative purpose. These diagrams are also representations. They are not the actual construction of the valve. So initially, suppose your stem position is this, but this is, you can say that this is L. L is not the length of the stem. L kya hai? L is not the length. L is the distance traveled by the stem. So this is L is equal to 0. What is L? Kahin likh lo yahan pe. L is the distance traveled by the stem, or we call it stem movement. What is L? Stem movement. कई बच्चे कहते हैं सर ये length of stem होता है, ऐसा नहीं होता. Stem movement. Now suppose air pressure is increasing, so for some value of air pressure, the stem will be somewhere here. I'm just using a different color to show another position of this stem. The stem will be here. ऐसा ही होगा ना? Now I can't show the movement of the stem here, so I have to use different timings, right? At some, this is time t is equal, not time t is equal to 0. So when there was no signal, the stem was present here. If there is some signal, the stem can be present here. If there is maximum signal, suppose, if there is maximum signal, the stem will be present somewhere further below this. The thickness of the stem will not increase. I'm just showing you so that you can understand it in a better way. ये नहीं भी बनाओगे तो कोई ज्यादा जरूरी चीज नहीं, but you should know. Now suppose this stem movement, this one up to this point is the maximum possible. भाई अगर ये stem यहाँ के टकरा गई, अब इसके बाद कहाँ जाएगी? कहीं नहीं जाएगी. There's a maximum movement. So this is L is equal to L max. This is L max and this is 0. राइट. सो ये जो स्टेम ने जो डिस्टेंस ट्रेवल किया उसको एल बोलते हैं. एंड वी कंसिडर दैट द डिस्टेंस इंक्रीजेस इन डाउनवर्ड डायरेक्शन, राइट. एंड इफ इट मूव्स इन द ऑपोजिट डायरेक्शन, ऑफ कोर्स ये जीरो से उधर नहीं जाएगा, बट द डायरेक्शन ऑफ मूवमेंट इज ऑपोजिट. वी कंसिडर दिस डायरेक्शन टू बी द पॉजिटिव डायरेक्शन एंड दिस टू बी द ऑपोजिट डायरेक्शन. या राइट. ओके, सो वी कैन डिफाइन हियर दैट x is equal to L divided by L max, means how much the stem has traveled. What is the maximum distance by, suppose the stem has traveled up to this point only, this is L, and this is L is equal to 0 and this point is L. Suppose the stem has traveled by this much. Okay, stem ने कितना travel किया? इतना travel किया. What is this? This is L. But if the stem travels by a maximum distance, what is this distance? This is L max. Correct? So L by L max is called x. So we call x as, मैंने यहीं पे बता दिया because I was discussing about the stem, so I thought that it is better if I discuss here only. X is the fraction of maximum stem movement. Now let me use a standard word, lift. कई बार ये भी लिख देते हैं, तो नाम पता होना चाहिए. You should know so that when you read the question, you should know that what is given, what is asked. So x is called the fraction of maximum lift or fraction of maximum stem movement. ये कुछ भी use कर सकते हैं. I hope it is clear that what is L and what is x, right? We consider that this direction movement is positive direction, right? And when, like suppose in this one, as you increase the air pressure, the stem was already present at this L max level. The stem is moving in the opposite direction. Now these are air to close and air to open valves. Now there is a question that, sir, out of these valves, which one is called direct acting valve, and which one is called direct acting, a reverse acting or indirect acting valve? Reverse acting is also called direct acting. देखो जो acting का ये जो फंडा है ना, direct, indirect, very simple फंडा. ये direct और indirect जो define करते हैं, whenever we say direct, whenever we say reverse, it's all about how input and output are related. Suppose you're doing a particular type of change in input and the similar type of change is occurring in output, then the thing is called whatever thing. ऐसा नहीं कि valve is only direct or indirect. Controller can be direct or indirect. Positioner, valve में component होता है, that is called positioner. Positioner can be direct or indirect, right? So this being direct or being indirect is totally related by the change in input and the change in output. Suppose you are increasing input. I'll tell you that what is which one is called direct or reverse. But उससे पहले direct or reverse का फंडा समझो. What is the fundamental thing? Suppose you are increasing input, any input to any device, you are increasing input. If the output is also increasing, then it is direct. Same kind of change, you see, in the input and the output, same kind of thing, same kind of change, same nature of change. Suppose you are decreasing input. If you are decreasing input and the output is also decreasing, direct. ऐसा नहीं करेगा indirect हो गया सर. देखो, nature of change should be same, then direct. If nature of change is opposite, then indirect. और indirect is also called reverse. मैं लिखूंगा नहीं, बता दे रहा हूं, indirect is also called reverse. Okay, indirect acting is also called a reverse acting. ठीक है? So if input, you are doing a change in input, the nature of change in input is, suppose increase, the output is also increasing, it is called direct acting. The nature of change in input is decrease, the output is also decreasing, it is called reverse acting. Decrease, no, it is called direct acting. But suppose if you are increasing the input, but output is decreasing, opposite nature, reverse acting. If you are decreasing the input, output is increasing, opposite nature, reverse acting. तो ये direct action and reverse action का यही फंडा है. ये फंडा पता होना चाहिए, ठीक है? But the question arises कि सर ठीक है, I understood that if you are increasing input and output is also, I mean, change of input and output, if they are having same nature, then it is direct acting. Change of input and output, if they are having opposite nature, then it is reverse acting. Correct? So, ये तो समझ आ गया कि सर ठीक है, how to define direct, how to define indirect. But how I'm going to decide that what is output and what is input? That is the question. Now, in this case, you will have to know the things only. आपको पता होना चाहिए बस. There is no way to learn this. There is no way to derive this. Now, in case of valve, the input is considered as the actuating signal, right? And the output is considered as the stem movement. Many students consider कि sir output is this flow rate. No, it seems that this output is the flow rate and input is the actuating signal, but it is not like that. In case of valve, the input is treated, the actuating signal is treated as the input, and the output for deciding direct or indirect action is considered as the stem movement. Now you see yourself here, actuating signal is increasing. What is the stem movement? The stem movement is taking place in this direction, and I told you what is this direction. This direction is considered as, आप कह सकते हो, there is a decrease in the stem movement. If the stem travels in this direction, there is a decrease in the stem movement. So if I'm increasing the input and the output is decreasing, then what kind of valve it should be? Reverse acting valve. यही fundamental है valve का. That is why air to open valve should be called as reverse acting valve. Now many students make here a confusion. कई बार टीचर्स भी कई कंफ्यूज करते हैं कि सर here actuating signal is increasing, flow is increasing, so it is direct acting. No, valve is decided whether it is direct acting or not on the basis of increase in the actuating signal and the stem movement, not on the basis of flow rate. तो एक काम करते हैं, इसको लिख लेते हैं, ठीक है? ये यहां से इसको मिटाते हैं, ठीक है? लिखते हैं यहां पे. सबसे पहले फंडा समझ आना चाहिए, that what is the meaning of direct action and indirect action, right? Okay, so write down the action of valve. The action of valve, देखो actually this direct action and the reverse action valve you will not find written even in a single book of process control. Yes, you can go for some, you can do some research on the internet, you may find written some things, but again there can be controversy as well. Plus, on the basis of direct and reverse action control valves, the last time the questions were asked around 2007 and 2008. After that, there was no question on reverse or direct acting controllers or control valves. Okay, so if there was no question on this valve, you can expect कि question आ सकता है. But again, don't create panic for a small concept कि नहीं सर यहाँ पे ये पढ़ाया हुआ है, यहाँ पे ये आंसर दिया हुआ है. And yes, related to these questions, these concepts, there are some question in GATE exam, 4-5 questions. Not even a single book or single source is there who is giving each and every answer correct. वो अपने खुद की बुक में कॉन्ट्राडिक्ट कर देते हैं. एक जगह डायरेक्ट बोलते हैं, दूसरी जगह अपनी बुक में उसको रिवर्स बोला हुआ. So there is a contradiction. So don't follow any resources. और ये तो बिल्कुल मत कहो कि सर देखो आपने ये पढ़ाया था और यहाँ ये लिखा है, कि आप जहां लिखा हुआ आप जहां से देख रहे हो that is not a reliable source. ठीक है, तो या तो आप रिलायबल सोर्स को देखो, और अगर कुछ नहीं देखना है तो जो यहाँ पढ़ा रहा हूं उसको मानो, और अगर सवाल आता है तो लिख देना. प्रोबेबली नहीं आएगा क्योंकि काफी टाइम से नहीं आया. आई एम नॉट एक्सपेक्टिंग कि देयर विल बी अ वेरी गुड क्वेश्चन बेस्ड ऑन द एक्शन ऑफ वॉल्व्स, बट स्टिल समझते हैं इसको. द एक्शन ऑफ वॉल्व इज डिसाइडेड according to nature of change. देखो किसी का भी एक्शन, इसको मिटा ही देता है ना, आपने बना लिया होगा. किसी का भी एक्शन डिसाइड करना है, whether you want to decide the action of a controller, you want to decide the action of a control valve, whatever you decide, the action is always decided by change in input and change in output. The nature of change you are doing in input and the nature of change it is occurring in output, right? So the action of valve is decided according to nature of change in actuating signal and nature of change in stem movement. Nature of change in stem movement. Right? These are the input and output. इट इज नॉट डिसाइडेड अकॉर्डिंग टू द फ्लो रेट. प्लीज नोट, ये नोट कर लेना कि वॉल्व का एक्शन द फ्लो रेट थ्रू द वॉल्व से कभी भी डिसाइड नहीं होता है, ओनली बेस्ड ऑन द एक्चुएटिंग सिग्नल एंड द स्टेम मूवमेंट. नाउ फॉर एयर टू क्लोज वॉल्व, फॉर एयर टू क्लोज valve, for air to close valve, as air pressure means the signal, as air pressure increases, what you have studied, as air pressure increases the stem movement. flow के बारे में नहीं सोचना, flow decrease करता है, but I'm not talking about flow. stem movement को क्या होता है बताओ. I told you that downward direction is considered as increase in the stem movement because this is 0 and this is L max. stem movement increases. ऐसे देखना है. If you are increasing the actuating signal to a valve, the stem movement increases because downward direction is increase in the stem movement. This is position 0 for the stem movement. This is position L max for the stem movement. So stem movement increases. You can see that the nature of change here and the nature of change here is same. What kind of valve? Direct acting. कई बच्चे यहाँ लिख देंगे कंट्रोलर. कंट्रोलर नहीं भाई, valve. Any component can be checked whether it is direct acting or not, depending upon the change in nature of input and nature of output. Similarly, for air to open, for air to open valve, as ये बहुत बच्चों की confusion रहती है, and you know कोई अगर ढंग से कंट्रोल की तैयारी भी करता है, ये वाला पार्ट ना उसको वो पढ़ता है ना उसे पढ़ाया जाता है. एंड अल्टीमेटली कि सर ये कुछ क्वेश्चंस है जो सॉल्व नहीं हुए, पता ही नहीं किसी को, कोई बताएगा नहीं आपको, आप खुद भी नहीं पढ़ोगे, कभी सॉल्व नहीं कर पाओगे, है ना. सो फॉर एयर टू ओपन वॉल्व, एज द एयर प्रेशर इंक्रीजेस, व्हाट हैपेंस एयर टू ओपन? In case of air to open, as the air pressure increases, the stem moves upwards, and upward direction we consider decrease in the stem movement. Air pressure increases, stem movement, so we call it stem movement decreases. इसलिए मैंने आपको पहले ही बता दिया, stem movement is considered to be positive in downward direction. Stem movement decreases. If this change and this change is of opposite nature, then what kind of valve it is? Reverse or indirect acting valve. यहाँ पे मैंने बहुत बड़ी confusion आप लोग की शायद दूर कर दी होगी, मुझे पता है पहले से ही आपको नहीं समझ आता है. Reverse of or indirect acting valve. That which valve is called as direct and which valve is called as indirect. अब एक चीज यहाँ पे मैं अभी से बता दूं कि ये कहीं पे कुछ भी लिखा हो आपको वो नहीं मानना है, ठीक है, या तो इस टॉपिक को ही छोड़ दो, कोई बात नहीं. अगर आप इस टॉपिक को लेकिन अगर इसी टॉपिक पे आप बैठ के डिस्कशन करोगे, सर यहाँ वो दिया है वहाँ वो दिया है, उसका कोई फायदा नहीं होगा. इट इज बेटर बिकॉज आई टोल्ड यू दैट मेजॉरिटी ऑफ द कंट्रोल आई हैव कवर्ड. द मोमेंट वी फिनिश्ड दैट ट्यूनिंग पार्ट, आफ्टर दैट द कंट्रोल पार्ट इज फिनिश्ड. Now this is only for theoretical discussions and there are few questions from this topic. So this is what is about the direct and reverse acting control valve. Any component can be checked whether it is direct acting or not. What you have to compare? See the nature of change in input and the nature of change in output. If they are same, direct acting. If they are opposite, reverse acting. But yes, you should be careful that what is input and what is output. That is very important. Now the question is, okay, this is done. We have solved the problem that why we should call air to close as direct acting, because many students try to relate it with the flow rate and then they feel कि sir air to close तो indirect होना चाहिए. Now the question is how to choose a particular valve. choosing fail open or fail close valve. Again a very important conceptual topic, fail close valve. Suppose there is a process and I ask you that for this process which valve I should choose, air to close or air to open. What do you think? कौन सा valve हमें choose करना चाहिए? The selection of the type of valve based on their failure position means we can say that selection of fail open or fail close valve is completely dependent on the process. What type of process you have. तो बिना process बताए I can't say that which one I should have. It totally depends upon the process. Keeping in mind the safety considerations. Write down. Failure position of the valve. Failure position of the valve is selected considering बड़ा बड़ा लिख लेना, considering fail safe position, considering fail safe position. I don't think it is very difficult to understand a fail safe. The question was that, sir, how I am going to decide that whether I should go for air to close valve or air to open valve? The answer is, it is decided on the basis of fail safe criteria. Means अगर failure हो गया तो भी आप safe रहोगे. Means the selection of fail open or fail close is based on this safety purpose. अगर system fail हो गया, system fail होने का मतलब the output from the controller is cut. If the output from the controller is cut, in that case also your system should be safe. This is called fail safe. What is the meaning of safe? Okay, let me write this. It means, बहुत clear meaning है, फिर भी कुछ लोग इसको नहीं समझ पाएंगे. That is why I am writing. It means even if the controller output is cut, means there is no pressure from the controller, the process should be safe. तो मतलब इसके पीछे कंट्रोल का कोई फंडा नहीं है क्या इनके सिलेक्शन के पीछे? नो, देयर इज नो फंडा ऑफ कंट्रोल फॉर सिलेक्टिंग एयर टू क्लोज एंड एयर टू ओपन, राइट? सो इट मींस इवन इफ द कंट्रोलर आउटपुट इज कट, द प्रोसेस should be safe. Ultimately, in chemical industry, I told you that safety is the thing. Now, how you are going to decide? Just apply common logic, simple logic without applying extra brain. Don't apply extra brain here. आप बोलोगे सर अगर कोई ऐसा केस बना दिया जहां दोनों सेफ रख सकते हैं, ऐसा क्वेश्चन नहीं आ सकता. Then there is no criteria for selecting air to open or air to close. ऐसा नहीं कि ये हमेशा बेटर होता है. बाय डिफॉल्ट वाला कोई सीन नहीं है यहाँ पे, जबरदस्ती के कॉन्सेप्ट नहीं. सपोज I am having a situation, case 1, ध्यान से समझना. I am having a situation and I am talking about the selection of valve, कि आप कौन सा valve select करोगे. Suppose I am having a situation that there is a reactor. In this reactor, exothermic reaction is taking place, right? We have studied reaction engineering. In exothermic reaction, heat is released, but I have a set point of temperature that I want to maintain this temperature at 70 degrees Celsius only, suppose. But this is an exothermic reaction. If you want to maintain its temperature, आपको जो heat release होगी उसे कहाँ निकालना पड़ेगा? You have to remove the released heat. So what you have done? You have a coolant, a cooling coil here, cooling jacket. Cooling jacket is there, right? In this jacket, coolant flows. Suppose this is the coolant and there is a valve. This is coolant in. Coolant in. Coolant is going to the jacket and then coolant is leaving. Of course, this coolant is going to remove the heat released during the reaction, and like this I can control the temperature, right? So loop banana hai. Okay, let us make the loop. There will be a temperature transmitter, there will be a temperature controller. तो this controller, this is a feedback control. इतना तो आपको आना चाहिए, इतना आना चाहिए. एक बार इंटरव्यू में डायग्राम बनवाया गया था मुझसे, है ना? इतना आना चाहिए आपको. That you can make a simple feedback control loop. Set point will be provided to this controller. This controller is going to adjust this valve flow rate, correct? This is the controller giving output of the valve, and this is the process. Now what do you think? What should be the type of valve here? अब मैंने आपको situation दे दी. If you have the situation, it should be easy for you to make a decision. Without giving the situation, if I ask you that which valve is better, then there is no answer for this. आप फिर इस पे बहस करते रहो, उसका कोई मतलब नहीं है ना? Okay. So जब मैं कहता हूँ कि हाँ इस चीज पे बहस नहीं करनी है, कई बार तो भी बच्चे उसी पे लगे रहते हैं. कई बार मैंने आपको कई बार समझाया. अभी रिसेंटली देयर वाज अ क्वेश्चन, बच्चे उस पर डिस्कस कर रहे थे. मैं बोला था कि क्वेश्चन भाई ऐसे ही है, इसको किसने बनाया, क्या बनाया मालूम नहीं, जबरदस्ती की कंफ्यूजन क्रिएट कर दिया, समझा दिया सब कुछ. फिर थोड़ी देर बाद एक बच्चे का मैसेज आया, सर करेक्ट आंसर बी होगा क्या? वेस्ट है यार, उसकी डिस्कशन ही नहीं करनी है. आपको मैंने लास्ट लेक्चर में ही बताया था कि क्वेश्चन अगर डिस्कस करना है तो गेट का करो, ठीक है? टेस्ट सीरीज के क्वेश्चंस, असाइनमेंट के क्वेश्चंस कर लिया, सॉल्व हो गए, ठीक है. यू जस्ट चेक कि आपको कॉन्सेप्ट आता है कि नहीं आता, उसके पीछे ज्यादा दिमाग नहीं लड़ाना. क्या पता बनाने वाले ने मजाक में आपको 1 मिनट में क्वेश्चन बना के दे दिया और आप उस पर 1 महीने से लगे हुए, क्यों, है ना? सो डोंट डू दिस, ओके? सो इवन if you find a question that which valve is better, air to close or air to open, which we should select every time, there's no answer for this. If you give me situation, then only I can decide. Now you tell me this is the coolant. Obviously you want that, suppose this is the controller supply. Suppose in some situation this supply is cut. What do you expect in that case? What is desirable in that case? Suppose this supply is cut, means the controller fails. If I select fail close, तो क्या होगा? When the supply is cut, the valve will be completely closed. समझ आ रही है बात? If I select the valve as fail close valve, when the controller signal is cut, the valve will be completely closed. In that case, there will be no flow of coolant from here. और अगर coolant flow नहीं करेगा, then there will be increase in this temperature. We never want increase in temperature in case of reactions or in case of chemical process. If you want to maintain the temperature at 500, we don't want it to increase, because increase in temperature is always harmful. I mean, after some temperature, definitely there will be cracks in the body of the reactor. There can be a major accident. So we never want this temperature to increase. So what we want that even if the supply is cut, the valve should be completely open. भाई कूलेंट के फ्लो करने से कुछ नुकसान तो नहीं होगा ना, कूलेंट फ्लो करता जा रहा है, इट कैन ओके, इन दैट केस योर सेट पॉइंट वोंट बी मेट. ये मत कहना कि सर उस केस में टेम्परेचर बहुत नीचे आ जाएगा, एक्सीडेंट तो नहीं होगा ना. देयर विल बी सेफ्टी वी हैव टू इंश्योर. सेट पॉइंट तो बाद में बराबर करते रहेंगे, बट वी हैव टू इंश्योर सेफ्टी. Okay, so what we expect here, that in case of failure condition, because it is coolant, so valve should be open. So which valve should be selected here? फेल हो जाए तो वॉल्व ओपन रहे, ऐसे याद रख लो. फेल ओपन मींस एयर टू क्लोज. सो फॉर दिस काइंड ऑफ सिचुएशन आई विल सिलेक्ट एयर टू क्लोज वॉल्व, राइट? नाउ मेनी बुक्स और at many various places there is a rule given that if the line is carrying a cooling water, obviously देखो अगर line में cooling water है, then obviously this cooling water is going somewhere to cool down something, and we always want this valve to be open. In that case we should have fail open valve. And if the line is carrying steam, heating steam, suppose the same situation is there, but now I don't have exothermic reaction, I have a boiler, and in this boiler there is a valve. Suppose this boiler is, okay, this is steam in, ऐसा एक modeling करी थी ना हमने, we have done the modeling of this. This is T in and this is T out. Now you tell me, this is carrying steam. What do you think? आप control loop भी बना सकते हो. Which type of valve it should be? Obviously, suppose if the controller fails, बना लेते हैं control, temperature transmitter, temperature controller, and we have the set point TSS. If the controller fails and suppose the valve is completely open, means I select fail open valve here, right? I select fail open valve here. In case controller fails, the valve will be completely open, steam will continue to pass, and if steam passes, the temperature will again increase. So in this scenario, which valve I should have? I should have कि अगर controller fail हो गया, because steam is there, steam is high temperature steam, it is going to increase the temperature of my system. So which valve I should have here? Fail close means air to open. So you can see basic logic से decide करना है कि कौन सा valve choose करना है. So there you can consider a basic rule that if the line is carrying a cooling water, then I should select fail open valve. If the line is carrying heating steam, I should select fail close. But let me tell you, there can be exceptions. Right? तो ये ऐसा रूल नहीं है जो हर जगह वैलिड होगा. There can be exceptions that a line is carrying cooling water and still I have to go for fail close. So there can be a case. कौन सा केस होगा पता नहीं, आपको भी सोचने की जरूरत नहीं है. But that is why I'm saying, if there is a scenario given to you, check the scenario and apply basic logic that when the controller fails, your process should be safe. So this is how we decide that which valve should be selected. And I told you that out of this fail open or air to close is called direct acting, air to open is called reverse acting. So now you know that what are the type of valves. Now you know that how I am going to decide the which valve I should select. Now the question is just like we have a direct and reverse acting valves, we also have direct and reverse acting controllers. Let us write. ये मिटा लेते हैं, आगे बढ़ते हैं. Put the heading direct and reverse acting controllers. You may ask, sir, we are discussing here valves. Why you are discussing controllers here? About the action of controller. The thing is, without understanding the type of valve, I can't decide the action of controller. That is why I have to discuss here the action of controller. Okay. The same concept applies here. The same concept that if change in input and change in output, their nature is same, then we have direct action. Concept वही है. लिख लो. Action of controllers. Action of controllers. Okay. How to check the action of controller? If measured variable, do you understand what is measured variable? The variable which we are measuring, which is if it is a feedback control strategy, then it is also the variable which we are controlling. Okay. So if measured variable increases and controller output also, controller output, not the output of the valve, we are checking the action of controller. तो मुझे controller का input और controller का output देखना है. Okay. So this is measured variable. If this increases and controller output increases, then direct acting controller. ये कोई नई बात नहीं बता रहा, मैंने इससे पहले जो बताया वही है. ठीक है ना. If measured variable decreases and controller output increases, then it is reverse acting or indirect acting, same thing. Other two cases are also possible. If measured variable increases and controller output decreases, then also the controller, अच्छा ये ध्यान रखना भी, direct acting valve मत बोलना है, direct acting controller. These are two different things. Controller. Okay. Then it is called, you can see the nature of change is opposite. Reverse acting controller. Okay. Similarly, if measured variable decreases and controller output also decreases, then it is called direct acting controller. So, how to decide? Can we take some examples? Yes, of course we can take. Okay, this is how we decide the action of controllers, that the controller is direct acting or reverse acting. ठीक है, तो मैंने यहाँ सारे cases लिख दिए. ठीक है. Of course, again the definition of direct and indirect is again the same thing, that if the nature of change in input and output is same, direct acting. Nature of change in input and output is opposite, then it is reverse acting. Let us take one example. Before deciding that what is the nature of controller, we must know the nature of valve. That is why I am discussing this topic here. Before deciding the nature of controller, we must know what is the nature of valve. Suppose this is a liquid level control system. LT, LC, sorry, this should be HSS, and then it goes to the valve. Correct? This is a liquid level control system. Fine. Now suppose, let us first decide, see, without deciding the nature of valve, यहाँ पे लिख लेते हैं, without deciding the nature of valve, we can't decide the nature of controller. So nature of valve must be known. Nature of valve, controller action can't be checked. है ना? Controller action can't be checked. तो जब तक आप valve का nature ना decide कर लो, आप controller का action check नहीं कर सकते. Now तो यहाँ कौन सा valve लगेगा? Now there is no point of safety here. Here it should be mentioned in the question that suppose let that it is air to close. ध्यान से सुन लेना, ये दिया है, मैं check नहीं कर सकता यहाँ पे. There is no meaning of applying the safety criteria. ठीक है? So यहाँ suppose it is given that it is air to close valve. Now let us assume a scenario. Suppose let liquid level rises. let liquid level increases due to some disturbance. Liquid level increased. You know what is the disturbance here? So due to some disturbance, liquid level increase. You may ask, sir, why not decrease? You can also take decrease, not a problem. Again, things will be proved. So let liquid level increases. So I can say that measured variable, liquid level is the measured variable. So measured variable increases. Now measured variable increases. Okay? Let liquid level increases means measured variable increases. Now it is very obvious that if this liquid level has increased, the controller will try to open this valve, right? Controller decides, ये क्वेश्चन गेट में आया हुआ है और आंसर गलत दिए हुए सारी जगह, ध्यान से सुन लेना. Controller decides to open the valve. Which valve? There is only one valve. There is no valve here. To open the valve. कंट्रोलर, भाई कंट्रोलर तो हमेशा सही डिसीजन लेगा ना. कंट्रोलर हैज सम कोडिंग, कंट्रोलर हैज द एक्सपीरियंस, इट इज द ब्रेनी पीस. तो जिसके पास दिमाग है वो सही डिसीजन लेगा, है ना. सो कंट्रोलर टेक्स राइट डिसीजन दैट द एग्जिट वॉल्व हैज टू बी ओपन्ड. इफ यू ओपन द एग्जिट वॉल्व, द एग्जिट फ्लो रेट इज गोइंग टू इंक्रीज एंड द लेवल विल कम डाउन. वेरी सिंपल थिंग. सिंपल केस है तो कंट्रोलर बहुत सही डिसीजन लेगा दैट द कंट्रोलर डिसाइड्स टू ओपन द वॉल्व. नाउ यू टेल मी, वॉल्व हैज टू बी ओपन, देयर इज नो अदर चॉइस. वॉल्व को तो ओपन ही करना है, बट ये वॉल्व कैसा है? ये वॉल्व है एयर टू क्लोज. एयर टू क्लोज मीन्स इफ यू इंक्रीज द कंट्रोलर आउटपुट द वॉल्व विल बी क्लोज्ड. पर मुझे वॉल्व को क्या करना है? वॉल्व को खोलना है भाई, है ना. वॉल्व हैज टू बी ओपन्ड सो दैट द लिक्विड लेवल कम्स डाउन. फॉर द कमिंग डाउन ऑफ द लिक्विड लेवल दिस वॉल्व मस्ट बी ओपन्ड, बट दिस वॉल्व इज ऑफ एयर टू क्लोज. Controller decides to open the valve and that is right decision, right? But if controller output increases, then valve will close. बहुत सिंपल भाषा में समझा रहा हूं, ये भी नहीं समझ आएगा तो फिर मुश्किल है, ठीक है. इफ कंट्रोलर आउटपुट इंक्रीजेस देन वॉल्व विल क्लोज. कैसे पता लगा? हाउ आई नो दैट इफ कंट्रोलर आउटपुट इंक्रीजेस देन वॉल्व विल क्लोज? दिया हुआ है ना, एयर टू क्लोज. But the controller wants to open the valve, then what controller will do? Therefore, controller output will क्या होगा? Decrease. So that suppose in earlier the system was at steady state. Suppose earlier the controller output was 12 psig, so now it will be 9 psig or 10 psig. So at 9 psig controller output, less air pressure will be there and the valve will open. So CO will decrease so that valve opens. Now check this. The liquid level means the measured variable increases and the controller output decreases. So which case? Measured variable increases, controller output decreases. Opposite nature. What kind of controller it is? It is a reverse or indirect acting controller. However, what type of valve अगर पूछूं, valve का action क्या है? It is air to close valve. So what kind of valve it is? Direct acting valve. Valve is direct acting, controller is reverse acting. And don't think that only valve and controller can be direct or indirect. Even transmitter can be direct or indirect. It's all about the input and output. ठीक है? Okay. Now you may ask, sir, can I assume that liquid level decrease? And in that case, am I going to achieve the same result? Yes, definitely. See, if liquid level decreases, the measured variable decreases. आप यहीं पे देख लो, controller decides to close the valve so that level वापस ऊपर चला जाएगा, ठीक है. If liquid level decreases, measured variable decreases, the controller decides to close the valve. But if controller output increases, then valve will close. अच्छा, तो मुझे तो close ही करना है. If I have to close the valve, the controller is going to increase its output because it is air to close. And you can see the liquid level decreased, but the controller output is increasing. Again, reverse acting controller. Whatever example you want to take, you can take the example of the previous case when there was an exothermic reaction taking place. I told you, I gave the example, exothermic reaction taking place in a reactor. What kind of valve we were using? Due to safety consideration, I was using fail open. In the case of cooling water, it was fail open, means air to close. अब सोच के बताओ कि वो जो कंट्रोलर होगा वो रिवर्स एक्टिंग होगा या डायरेक्ट एक्टिंग होगा. उस एग्जांपल को सोचो बिल्कुल इसी तरह से. वेरी सिंपल टू अंडरस्टैंड दैट कंट्रोलर एक्शन इज रिवर्स और डायरेक्ट. सो इट्स वेरी सिंपल. इफ देयर इज इंक्रीज इन द मेजर्ड वेरिएबल एंड द कंट्रोलर, नाउ यू टेल मी, विदाउट अंडरस्टैंडिंग दिस कैन यू डिसाइड कि इसके आउटपुट डिक्रीज करेगा कि इंक्रीज करेगा? यू कांट. सो फॉर डिसाइडिंग वेदर द कंट्रोलर शुड इंक्रीज इट्स आउटपुट और डिक्रीज इट, देखो ये मत सोचना कि सर इफ आई वांट टू इंक्रीज दिस फ्लो रेट द कंट्रोलर आउटपुट विल आल्सो इंक्रीज. नो नो नो, it totally depends upon the valve, what type of valve you have. Correct? So without understanding the nature of the valve, I can't check. देखो यहाँ पे मैंने बताया ना, controller decides to open the valve. हाँ, जब तक मुझे ये नहीं पता होगा मैं ये नहीं बता सकता. That is why for checking the nature of the controller, we must know what is the nature of the valve. Then only I will decide that for opening the valve, the controller should increase the output or decrease the output, and then I can check the nature of the controller. तो ये एक्शन ऑफ द कंट्रोलर अगर आप ठीक से समझ रहे हैं तो गेट के वो 2-3 क्वेश्चन जो सभी की प्रॉब्लम रहती है वो बड़े मजे से सॉल्व हो जाएंगे. और ध्यान रहे आपका जो आंसर आ रहा है वही सही है, जो बुक में आंसर दिया वो सब गलत है. बेस्ड ऑन दिस फैक्ट, है ना, जो भी यहाँ पे समझाया इस हिसाब से जो आंसर आएगा दैट इज करेक्ट आंसर. एंड देयर हैज नॉट बीन एनी क्वेश्चन सिंस पास्ट 13-14 ईयर्स. सो ऐसा नहीं आएगा, बट इस पे ज्यादा और डेप्थ में जाने की जरूरत नहीं है.